This is lesson 4. This is on radical equations. So for our opening exercise, it says the numbers in each column are related. Your goal is to determine how they are related. Determine which numbers belong in the blank parts of the columns and write an explanation for how you know the numbers belong there. All right, so as I look at this column, and I am looking at these, I do see a pattern. So to find rule number 1, so 2 here I think should be squared to 4. The square root of 81 would be 9. 15 squared would be 225. The square root of 49 would be 7. 10 squared would be 100. 12 squared would be 144. The square root of 169 would be 13. M squared would be m to the second power. And n would have the square root of n. The next one, as I look at this, and I see here we have 3 and then 27, 6 and 216. I am looking at the numbers cubed. So 2 cubed would be 8. 125, the cube root of that would be 5. 11 cubed would be 1331. This cubed root of 64 is 4. 10 cubed is 1,000. 7 cubed is 343. And the cubed root of 2744 is 14. P cubed is p to the third power. And the cubed root of q is written in this way. Okay. So now it says for example 1, for find the rule part 1, how were you able to determine which number belonged in the blank? Well, to go right, we square the number. On the left. Left, we take the square root of the number on the right. For rule part 2, it says, how are you able to determine which number belonged in the blank? On the right. We cube the number on the left. On the left, we take the cube root Let me fix that. Of the number on the right. And this guy should go up here. Sorry, I wrote the wrong way. Okay. So for C, it says, were you able to write more than one number in any of the blanks? So for C, it's going to go down here. Sorry about that. So the answer is no. And D, it says, were there any blanks that could not be filled? Answer is no. So then it says, we could extend the find the rule exercise to include an infinite number of rows, and in each case, we would be able to fill in the blanks. Therefore, we can say that the positive square roots and cube roots exist because only one number worked in each of the blanks. We can say that the positive roots are unique. So next, the symbol n on the outside to the square root of 1 is called the radical. We will only work with radicals where n equals 2. So for example, on the outside, 2 radical of the radical sign, which we call the square root. And n equals 3, which we will call the cube root. So to find the positive value of x that makes the equation true, in this case, we are going to take the square root of both sides. So here I'm going to take the square root of both sides. So the square root of x squared is x. The square root of 25 is 5. Next, we have, first of all, if you remember your rules for exponents, here we have to the negative 1. So the first thing I have to do is change that. So I have x squared. Let me fix that first. We have x squared equals 1 over 25. Now I can take the square root. I can take the square root of both sides. So the square root, I have x equals 1 over 5. The last one is a cube root. So I can take the cube root of both sides. And you can rewrite this, guys, if you want to. You can do this so that you have room and do it this way. So that you have room and you can see it better. So that way x equals 2. And this you can put in your calculators, okay? And you put it in your calculators this way. You put in 3, hit the second button, hit the arrow button, and then put in the number, and then hit equals. So next for the exercise, it has x to the second power equals 169. Explain the first step in solving the equation. We are going to take the square root of both sides of the equation. Then it says find the positive value of x that makes the equation true and check your answer. So the way that we do that is we have x squared equals 169. Take the square root of both sides. So x equals 13. To check our answer, we have x squared equals 169. Replace x with 13. So 13 squared equals 169. And then we have 169 equals 169. And it checks. So number 2 says a square-shaped part. And notice this. It is a squared shaped has an area of 324 feet squared. What are the dimensions of the park? Write and solve an equation. Check your solution. Well, the area of the park is 324 feet squared. Remember, a park fits like this, okay, is side times side, or side squared. So therefore, you've got side squared, a side squared, which equals 324. So I'm going to take the square root of both sides. So my side equals 18 feet. Okay, to check it, I have my area equals 324. So my side squared equals 324. Oops. So 18 squared equals 324. 324 equals 324. And it checks. Okay? So now, my next equation is x cubed equals 64. So I'm going to take the cube root of both sides. So x equals 4. To check it, x cubed equals 64. 4 to the third power equals 64. 64 equals 64, and it checks. My next one is x squared equals 256 to the negative 1. And of course, we've got to change that. So x squared equals 1 over 256. So I'm going to take the square root of both sides. So x equals, 1 over 16. Now to check this, we have x squared equals 256 to the negative 1. So we have 1 over 16 squared equals 256 to the negative 1. So here I have 1 over 256 equals 256 to the negative 1. So 256 to the negative 1 equals 256 to the negative 1. Our last problem is a cube has a volume of 26 inches cubed. What is the measure of one of its sides? Write and solve an equation and check our answer. Well, our volume is 27 inches cubed. Remember, volume is side cubed equals 27. So we're going to take the cube root of both sides. So in this respect, S equals 3 inches. So now when I check it, we have volume equals 27 inches. Oops. Inches cubed. So here we have S cubed equals 27. So 3 cubed equals 27. And 27 equals 27. And it checks. That is our lesson for today.